In this video, we'll take a look at how to graph the general vertex form y equals a x minus h squared plus k of a parabola or quadratic function. And we're going to take a look at a few examples. The one on this page, we're asked to graph y equals 3x minus 2 squared plus 1. So the first one, we're asked to describe the properties of the parabola, and we'll graph it and then answer questions B and C. To describe the properties of the parabola, these numbers here allow you to find or illustrate where the vertex is. So the vertex would be at 2, 1. Notice it's x minus the h, x minus the x coordinate, and that's why it kind of appears that this number is always the opposite, but it's not x plus h here. If this was actually x plus h, then we would have to use the actual number here with that sign. But because of the fact that it's x minus that number, if this says x minus 2, then 2 is the x coordinate of the vertex. It does say plus k in the end, so whatever this number is right here, if it's written in the proper vertex form, would be the y coordinate of the vertex. So we'll plot the vertex at 2, 1. There's the vertex. And because of the fact that the x coordinate of the vertex is 2, or this is 2 here, the axis symmetry will be x equals 2. And that line looks like this. It's a vertical line that cuts right through the middle of the parabola. The parabola will be symmetrical about that axis symmetry. Now the parabola opens up because of the fact that the a, or the 3 in this case, is greater than 0. So we know the graph opens up. And there's a couple of ways to sketch the graph at this point. You could use the step method, and I'll mention that after we find some points here. You could also just simply find a point on either side of the vertex and graph them, and then you tell if it opens very steep or very shallow. And what I'm going to do is find the point on the left of the vertex that has an x coordinate of 1. This is where x is 1 here, so we're going to find out what the y value would be, so we know where to plot that point. So in the equation, I'm going to substitute 1 in place of x. So there's my 1 substitute in place of x. And so 1 minus 2 is negative 1. If you square that, you get 1. And 1 times 3 is this 3. So there's the 3 times 1, plus this 1 on the end. So this would be 3 plus 1 gives you 4. So that's the y coordinate if x is 1. And so that's the point 1, 4. And we can plot that on the graph, so 1, 4 would be right there. Now by symmetry, there should be a point right across the axis symmetry right here. So if we were to put 3 in place of x, we should get 4 as well for y, so 3, 4 should be on the parabola. So I'll just illustrate that algebraically. If we put a 3 in place of x, again, 3 minus 2 is, in this case, positive 1, and 1 squared is 1. And so we have 3 plus 1 gives you 4 again. And so that certainly does work. So 3, 4 is a point on the parabola. And so we'll plot that point and then draw our smooth curve, our parabolic shape through all those points with the vertex here, of course. Now, the parabola does continue to go upward forever, but it also keeps on going out to the right and out to the left. And so that means that you could literally put any x value whatsoever in place of x in the function, any real number. There's no number that you cannot put in place of x. You can put any whole number, any decimal, any radical, any fraction that you want, that you can think of, a real number in place of x. So that's why we say the parabola is defined for all real numbers. X can be is a member of the set of real numbers. This funny capital R stands for the set of real numbers. Now, for any parabola that opens up or down, there's either a minimum point or a maximum point. In this case, we have a minimum point. The y value there is 1 because the vertex is at 2, 1. 1's the y coordinate. Every other y value is bigger than 1 and out this way as well. And so we would say the parabola has y values that are all real numbers, and this vertical bar stands for the words such that. So it's read, y is a member of the set of real numbers such that y is greater than or equal to 1. 1 being, of course, the lowest possible y value, every other one larger than 1. Flipping over example 2, it says determine an equation for the parabola shown. So here we have this parabola. If we look up here, this point right here is the point 3, 7, and that's where the vertex is. So the vertex is at 3, 7, so in that vertex form, that means that h would be 3 and k would be 7. Now, another characteristic of the parabola is it opens down, so the a value, the stretch value, would have to be is negative, so it opens down. So in the general vertex form, we still have to find what A is, but we can put 3 in place of H and 7 in place of K. And so that's what the vertex form looks like so far. We need just to find A, and then we'll know what the equation is. Now, one way you can find A is if you know that it's called the step method. Normally for a parabola, if there's been no transformations, if it's just y equals x squared, if you go from the vertex right one block or left one block, you're either going up one or down one, depending on whether it opens up or down. In this case, notice if you go left one block or right one block from the vertex, notice you're going down 2, so that actually means that A is negative 2. I'm going to show how to do this algebraically as well, but that's a really quick way to get it from the graph. So you can be pretty sure that it goes through that point pretty exactly, so A is negative 2, or I guess it's really, really close to negative 2. Now, in order to do this algebraically to find what A is, find a point that it passes through. For example, 2, 5, or for example, 4, 5 are points that the parabola passes through. And so what we're going to do, and there's my 2, 5 point, what we're going to do is substitute 2 in place of x and 5 in place of y and solve for A. So there's the 5 substituted in place of y and the 2 in place of x. And so we're going to algebraically solve for A here. Now 2 minus 3 is negative 1. Squared is 1, so this is just 1a, so 5 equals a plus 7. If we solve for a, we would subtract 7 from both sides, or take the 7 over and subtract it from the 5. 5 minus 7, of course, is negative 2, just like I said it was from the graph. So a is negative 2, so to write the equation, we would substitute negative 2 in place of a, and this is what our equation is. So that's an equation for this parabola in vertex form. In example 3, we have a surface-to-air missile that's fired from a height of 3 meters and achieves a maximum height at horizontal distance of 12,000. It's 5,000 meters off the ground. So that's its height when it's gone 12,000 meters horizontally. So it's fired from over here. It's hard to illustrate 3 meters on the graph here because we have such large numbers. Every block vertically, every block horizontally is 1,000. So the height of 3 is going to look like it's at 0. But basically it starts really, really close to 0. We have to remember that it has actually a height of 3. So this is 10,000, 11, 12,000. It's at a height of 5,000. Then, of course, it starts to fall because that's the highest point. So the variable on this axis I'm going to call capital H, not to confuse it with H in the vertex form. So capital H means the height. The little d is the horizontal distance here. So instead of having x in this axis, I'm going to use d. So instead of y equals a x minus h squared plus k, I'll have capital H equals a d minus h squared plus k. So I'm using different variables because of the context of this problem. Now we're told that the vertex is here at 12,000, 5,000. So that tells us what the h and k numbers are. So we know that much about the equation. H is 12,000. That's the horizontal coordinate of the vertex, and the height there is 5,000, so k would be 5,000. So we know this much about the equation. This is very much like the example 2. We just now have to find what a is. And we're told in the problem here that it's fired from a height of 3 meters, and at that point there'd be a horizontal distance of 0 because it hasn't moved horizontally yet. So if d is 0, h, capital H, is 3. So we can substitute those into the formula to find what a is. So if d is 0, it hasn't been fired yet. The height is just 3 meters off the ground. It's on the firing platform, I guess. So 0 minus 12,000, of course, is just negative 12,000. And if we square that, we get 144,000. I'm solving for a here, so I'm going to rearrange. I don't want the 5,000 left on the right side here, so I'm going to bring it to the left. So when we bring that over, 3 minus 5,000 is negative 4997. And then we would divide out this, actually it's 104, I think I said 144,000. It's actually 144 million, sorry, negative 12,000 squared. So we would divide out the 144 million, and that's the exact value for a. I would probably write it as a decimal to several decimal places. It's approximately negative 0.000035. So we would substitute that in place of a in the equation, and so that's an equation that would model this missile's path. And it's the equation we're going to use to answer question B. The missile continues to travel after its maximum and it engages a bogey, it says 2,000 meters after its maximum height. So the maximum height occurred at 12,000, so this would be at 14,000 meters horizontally. And so we're asked at what height does it hit this enemy target. So we're really asked just to find what the y value is, what the height is there. So we're solving for h, and the d would be 14,000. So in the equation, we'll substitute 14,000 in place of d, because that's the horizontal distance it's gone since it was fired. 14,000 minus 12,000, of course, is 2,000. And so we would square 2,000, and then multiply by this negative 0.000035, and then add it to the 5,000. And you can tell it really hasn't fallen much. It's only a little bit below the 5,000. Its height is still 4,860 meters. So that's the height that it would engage this enemy target at, 4,860 meters off the ground. And this last page is just a summary of basically vertex form. This is the equation that we're working with, and these are all the characteristics that we're going to talk about. So this is just a general vertex form. The axis symmetry is always x equals this h number. The vertex is at hk. This is the stretch or compression factor. If that number is less than 0, the parabola opens down. If it's greater than 0, it opens up. And of course the shape is its parabola. I can't draw a specific one here because I don't have a specific number for h or k or a. Generally, the possible values of x is x could be any real number. Now there could be a specific situation here where x couldn't, for example, be a negative. In the example on the previous page, the missile is fired, the horizontal distance would only be a positive number, so we wouldn't have to worry about negatives there. The possible values of y, generally, again, if a is less than 0, it's a downward opening parabola and there's some highest point, so the y's would be less than some number, and that's the y-coordinate of the vertex k. If a is greater than 0, it opens up and there's some minimum number, so some lowest point, so the y values would be greater than or equal to some number, which would be the y-coordinate of the vertex, which is the k. So a couple of specific examples. For this one, x would equal 1 for the axis symmetry, and the vertex would be at 1, 4. The compression or stretch factor is -3, so the -3 of course means that it opens down, the negative, and the 3 means it's stretched to be 3 times as steep really as the basic y equals x squared parabola. And if you look at the graph here, 1, 4 is my vertex, so over 1, up 4. It opens down. Now the stretch factor is actually, if you go right 1 unit, it's how many you actually would go down to get another point in the graph. And same with left. So we go left 1, 1, 2, 3. Notice it's going right through that point. That's a good, really quick way to graph the parabola. The possible value of x would be all real numbers. In fact, that's true for any parabola, unless there's some kind of restriction on it. Because there's a highest point here, 4 is the highest y value there, so the possible y values would be all real numbers except, of course, y is less than or equal to 4. For the last example here, y equals 2x plus 5 squared minus 3, the axis symmetry would be x equals -5. Remember, you actually would think of this as x take away -5 because it's x minus the number squared. So the x coordinate's -5. So the vertex would be at -5, -3, which is, of course, -5, -3 here. Since the a value of 2 is positive, it opens up. So it opens up. And again, the stretch factor, if you go from that vertex right 1 block, that's how much you go up to get another point on the graph, or left. So we start the vertex and go left 1, you go up 2 in this case to get another point on the parabola, and that's a quick way to sketch it. The x values, possible x values, would be all real numbers. Some people call that the domain, D-O-M-A-I-N, the domain of the function. There's a lowest point here. The y value is -3 there, and then all other y values are bigger than that. So the possible y values, which some people will call the range, R-A-N-G-E, would be all real numbers such that y is greater than or equal to -3. And that's the end of the lesson.